Hello everyone, welcome back again. Today we'll be going through the grade 12 November, let's make sure, to be November 2020, paper 2 for mathematics. We'll specifically be focusing on circle geometry, and this will be question number 8. There is a lot that is going to be shared in this question, just like our previous series of the circle geometry. So if you found the previous content useful, please like the video and comment if you have any questions. And also it will be much appreciated if you just press the subscription button so the video can be sort of recommended to everyone who is in need. Sure, let's go for question 8, and I'm going to read the statement and then we'll start dissecting the questions at hand. So the statement reads as follows. We have a diagram. I've tried to draw it here. It is not drawn to scale. So the statement reads as follows. O is the center of the circle, that is O. KOM bisects chord LN. KOM, let's locate KOM. There's KOM. It ends here. Don't mind this line here. They are saying it bisects LN, so this is LN. Just before we move past that, the difference between bisecting and intersecting. When two lines intersect, it means they meet. So there's no way that we can or two lines can bisect each other. One line can bisect another line if they don't intersect. So we know that before we can bisect, we need to intersect. But it doesn't mean when you intersect, you have bisected. So what does bisecting mean? It means that when you intersect that line, let's say point M, you are dividing that line into two equal parts. Or it means we are hitting that line at a perpendicular degree. So when you hit this line, the angle that is formed in there is 90 degrees. So specifically for this case, when we bisect it, we cut into two equal pieces. Also, but the most general or the most basic one, you need to understand that when you bisect a line, you are cutting it into two equal angles. It can be 90 degrees, it can be various angles. It just means that you are cutting that specific line into two equal angles. All right. Now that we've cleared the air on what bisect really means, let's move over to the next parts of the statement. K and P are points on the circle. So we have K and P. Noted. They are saying these points K and P are on the circle. Why did they have to tell us that? It's because everything in circle geometry needs to be declared before you can make assumptions. They told us this is a circle. You can see it looks like a circle, but they had to tell us that O is in a circle. And they tell us that KOM bisects these two. And yeah, then they are also mentioning that NKP, angle, NKP. So where is NKP? NKP. So the angle is that one. For more information of how to find angles using that method they stated here, please look at the previous circle geometry videos. All right, so there's also OP that is drawn, OP. Cool, let's go to the first question. The first question is asking us to calculate the value of O2. The question is 8.1.1a, calculate O2. Cool. To calculate the angle O2, before you start anything in circle geometry, I'll always repeat this. All what circle geometry wants from you is, first of all, love the subject. Love, because from love, that's when your brain will start working. It will start having these ideas just by looking at the diagram. So the first thing is that you must fall in love with the question at hand. And when you look at this beauty, try to understand the statement that you just read and see if you can note anything from that statement. And also, if you notice anything that reminds you of a certain theorem, do keep it in hand or write it down immediately so that you don't forget it. This is all jogging down ideas. This is all looking at these lines, combining or looking how these lines intersect, bisect, and make sense of them. That's the most important part, but don't forget the angles. All right, so when they are asking us to calculate the angle of O2, how would I approach this question, or how would I like you to approach the question? So you ask yourself, where is this angle located? Where is O2? There's O1, there is O2. Where is it located? We still haven't answered. This is just the number of the angle. It says O2. Where is it located? Okay. We see that this line is located in between two lines. There's a line OP and there's a line ON. And they told us that O is a center. All right. O is the center here, and that angle is located at the center. This angle is located at the center. So you should already be thinking, there's an angle at the center and I'm looking for it. What comes into mind? What theorems are associated with that? Angle at the center. Good, that's it. Angle at the center is twice the angle at the circumference. So you are jogging down ideas that probably you'll use this theorem. It's not that it's always that way, but it's always good to just overthink. If they don't ask a question like that, it's a plus for you. You are able to just look at a diagram, look at an angle and associate it to the specific theorem. All right, so we know that there's an angle at the center. There it is. Then you look, okay, what can I use? Now that I already know it's an angle at the center, we know the follow-up theorem is angle at the center is twice an angle at the circumference. Is it possible that there's an angle at the circumference here, which is subtended by the same arc? So that's the most critical thing. If you, for instance, look at that theorem, angle at the center, it specifically states that if you have this angle at the center, you have something like this, and there's an arc, let's say BC. This angle here is twice an angle at the circumference, but that angle needs to be subtended by the same arc. So there. So imagine if you had something like this now. Just trying to differentiate. So if you had, there's another angle, let's call this angle A, let's call this angle E. And then this is Z, this is X, Y. So do you notice that this is an angle also at the center, if that's our center? And if you were to draw another line like this, I know it's a complicated diagram, but get the point. This is an angle at the center, this is also an angle at the center. But this angle here, we can't say this angle is twice this angle right here. We can't link these two angles because they are not subtended by the same arc, or if there's a chord, by the same chord. But if these angles are subtended by the same chord, then I can definitely know that the angle at the center is twice the angle at the circumference, and it doesn't have to be at that point. It can be tilted anyhow, but if they are subtended by the same chord and there's an angle at the circumference, there's an angle at the center, those two are linked. Now back to the question. Using that same concept, this is an arc PN, it subtends O2. Which other angle, let's say, is at the center, or is at the circumference that is subtended by the same arc? So let's look. Angles at the circumference are, there's no angle here, there's an angle here, K2, but is it subtended by the same arc? Here's K2. Don't mind this guy, but it's not even reaching the end of the circumference. So this is the only angle. You can see that this is the same arc that subtends this one. This angle is at the circumference. Most important part is at the circumference and is subtended by the same arc that subtends O2. So angle at the center is twice the angle at the circumference. O2 is equal to 2 multiplied by, so twice the angle at the circumference, that is K1. The reason, angle at center twice angle at circumference. Did you understand that? If you have any questions, just drop it in the comment section below. All right. What is the value of K1? It's easy. There is 32. So we're looking at 2 multiplied by 32 degrees, which is 64 degrees. We are done. So O2 is 64 degrees. Now let's look at the following question. Now this question, we are being asked to calculate the value of O1. Okay, O1, I'm going to scrap this guy and keep the value of O2. So you go back to your diagram. Now that you've found the value of O2, note it there. O2 is 64 degrees. All right, so now we are to find O1. How do we calculate O1? So let me write it as A point B. Okay, now let me wipe it. Okay, calculate the value of O1. Same approach. What is O1? It is an angle. Where is this angle? You locate the angle. What is special about this angle? What surrounds this angle? Can I make sense of the lines that surround this angle? Okay. O1. There is O1. There is O1. Where is it? Where is this angle? Same as O2. This angle is still at the center. There's an angle at the center. This angle, can I link it to the theorem that I've just used? So I need to find that it's an angle at the center, but is there any other line that goes to the circumference that is subtended by the same arc or chord? So you can already see that no matter how much you look in here, you won't find it. So we already know that even though we can note that it's an angle at the center, we won't be using that theorem. It's fine. What else is surrounding this angle? This angle is in this triangle. There's a triangle now here. The angle is in this triangle OKP. So it's also in a triangle. It's also in a triangle in OKP. So it's in triangle OKP. What is special about triangle OKP? Do we have angles in there? What is special about that? So you already look, okay, what is this? Do we have K2? No, we don't have K2. Do we have KPO? So do we have this angle? No. What else is special about this? This triangle has two lines that are coming from within that angle. They come from the center to the circumference, center to the circumference. These lines must be equal. Why am I saying that? A line from the center to the circumference is called a radius. So radius will always be equal. Those lines are equal. And if a triangle has equal sides, that triangle is an isosceles triangle. Isosceles. This is just me playing around the diagram, looking at the angle. It might not fit into the notes and you might not have time during the exam, but once you practice this method and always approach circle geometry like this, I'm telling you, it will save you a struggle. Alright, isosceles triangle. What else? This angle is still in this line. You already see this. This angle is within this line. Do you see that it's in a straight line also? So one last thing is that it's in a straight line. Okay, those are the 3 points. But in that straight line, do we have O3? No. Do we have O2? Yes. Do we have O1? That's what we are looking for. Okay, so you ask yourself, what is the easiest method? Because we don't want to work too hard here, we need the easiest methods. Okay, what is the easiest method to find here? We can go for angle at the center. We've scratched that. We can't go for you, buddy. We leave you. In triangle, isosceles triangle. Can we use isosceles triangle? So isosceles triangle, it will mean that we need to first find O. So KPO, we need to get this angle. We need to get this one so that we can calculate this one. So it's how many steps? We get this, and then we can calculate this one. So for this one, we need 3 steps. 3 steps. And within those steps, there might be other stuff we need to do, but we know minimum 3 steps to find this angle. So we'll be looking at the triangle. We need to, because angles in a triangle sum up to 180 degrees, we'll need to find other angles so that we can calculate that one. All right. Let's look at the straight line. In a straight line, we need to find O2, which we have. We need to calculate O3. Then from O3, we can figure out how much is the remaining, because angles on a straight line must sum up to 180 degrees. So in here, we only need to find one, minimum 1. So for this one, we need minimum 1 step. Not 1 step, we need at least 1 calculation, 1 angle to calculate in there. All right. Now let's begin. So definitely we're going with the straight line. So our mission is to find O3. Okay, same approach. Where is O3 and what else around O3 can I use to calculate it? So O3, the same as O1, is in the center, but we've already, just like O1, we cannot calculate that. So O3 is in a triangle also. This triangle has this angle, but we don't have M2. Can we find M2? Now we're adding. So we no longer are using 1 step, we're adding another step plus 1, which is still better than that 3. So can we calculate M2? Ask yourself the same question, where is M2? M2, we were told that, because M2 is in a straight line. So, and what is special about the straight line is that there's a line from the center that bisects that line. Line OM bisects LN, or KOM bisects LN. What do we know about the line that bisects and is coming from the center? It is always perpendicular to that line. I explained this on the start of this video. So we already know that M2 should be equal to 90 degrees. Angle M2 should be 90 degrees. Why? Because line from center, perpendicular, okay, bisecting chord is perpendicular to chord. Hope you'll see that. What I'm saying here is that if a line comes from center and bisects a chord, it will always be perpendicular to that chord. Same applies. If a line from center is perpendicular to that chord in there, it will mean that chord is being bisected. That's the theorem. So we already found M2. This is good stuff. We can note that M2 is now 90 degrees. Can we calculate O3? Yes. O3. O3 is equal to, so O3 plus M2 plus M should sum up to 180 degrees. Those angles should sum up because they are angles in a triangle. Angles in triangle. Then you name the triangle. The triangle is ONM. They sum up to 180 degrees. So you can find the value of O3. So what is O3? 180 degrees, you subtract 26, and then you subtract 90 degrees. All right, let me get a calculator for this. All right, we're back. You've seen what I just done there. Could have went on, calculated in my head. I know it's perfect, but rather be sure, rather be safe than sorry. If you can use your brain to calculate everything's good, but if you can confirm it, it's even better. I mean, it's just a few clicks away. So 180 degrees minus 26 minus 90, that is equal to 64 degrees. All right. Now that we found O3, we mentioned that we can find O1 because it's in a straight line. So we know that O1 plus O2 plus O3, this should sum up to 180 angles in a straight line. Angles in a straight line. Angles in a straight line. So what is the value of O2? What is the value of O3? You can calculate that. So that's O1 will be equal to 180 minus 64 minus 64. And that is equal to, what is the answer? 80 minus 64 minus 64. That's going to be 52 degrees. Alright. We've just calculated the value of O1. It's a tedious, long process, but I'm telling you, you'll be sure that you nailed these marks if you follow these steps. And of course, I forgot to mention, so you see that we calculated three angles here. M2, we had to calculate O3, then O1, which means that what you're going to use in here for using the triangle, you are going to calculate, we predicted 3. So there's a tie, so you choose what you might go with. If you want me to do an approach where I use that triangle, hit me up on the comment section, then we can look into that. All right, let's go to the next question. Question 8.1.2. Question 8.1.2 is asking us to prove that Kn bisects OKP. All right, let's locate these lines or angles that they're talking about and make sense of them, and also further analyze the statement. So where is Kn? There is Kn. Kn. They are saying we must prove that it bisects OKP. And where is OKP? There is OKP. Forgot to replace this guy here. We have 52 degrees. So let's prove that this line bisects this angle. This is the angle they're talking about. So I just want you to take a deep breath, rethink, or go back to the start of this video. Ask yourself, what does bisect mean? You should be back by now. Bisect means that the way a specific line intersects whatever lines that follow it, or where it basically intersects it specially. And what does this special mean? It can either cut it such that it's in two equal parts, which sometimes is not always the case. But the most important rule is that when it cuts and there was an angle there, and you say you are bisecting the angle, it means that angle you're cutting it into two equal parts. Let's consider a line. That's the point. If you have a line, you know that this angle will always be 180 degrees. If you draw a line that intersects that one, it can either intersect it this way, You can intersect it this way or this way. A line intersecting another line just means they meet at some point. But when they say bisect, that's a special kind of intersecting. Okay, so which line here bisects? Let's say this one, when it intersects here, it forms 30 degrees. This one also 30 degrees relative to this point, 30 degrees. But this one forms 90 degrees. Which line bisects? This one. The rule of thumb is that when the line bisects another one, it cuts into two equal angles. So let's remove the other junk. So if you were to draw a line here that forms 90 degrees, but you already know that this is 180, it means we cut this line into two equal angles, which is 90 degrees. That's what bisect means. Now let's go back to this question. What does bisect mean in this sense? Same analogy, KL bisects OKP. It means it must cut into two equal parts. We already have 32 degrees here. We need to find or prove that K2 is indeed equal to K1. How do you go about that? Same strategy. So it means the question is find the value of K2. What is K2? What is K2? Same approach. Where is K2? What surrounds K2? Can we make sense of K2 with the lines surrounding K2? What theorems does that sense we're trying to make? What theorem does it relate to? Okay, there is K2. Where is this line? Or where is this angle? This angle is at the circumference. There it is. An angle at the circumference, you ask yourself, oh, that can be half of the angle at the center, but is there an angle at the center? And like we spoke on the previous question, we can't link this one to an angle at the center. Okay, this angle is also forming part of two triangles here. There's this triangle, then, oh, actually even three. There's this one, and then there's this big one. So this angle is quite involved. So we ask ourselves, so we note that thing down. So this angle is in triangle OKP. Is in triangle, this triangle. So it's OKN. No, triangle OKN, and it's also in triangle NKM. In triangle NKM. So the following step comes is if I were to use a specific triangle there, what are the minimum steps that I need to go about to find that angle? Then you note it there. You might be wrong that you'll need more steps, of course, but this is the minimum that we're talking about. And of course, if we predict a lower minimum than the other one, it means that path is easy. And we like easy stuff in here. But it's not about being easy, it's about understanding what we're doing and can we do it in a fast way. Cool. OKP, there's OKP. For OKP, we need to know the value of OPK. So we need to know the value of this angle and we need to know the value of this one, so that we can calculate OKP. But we have the value of Q of O1. Yes, we do have the value of O1. Do we have the value of P? No, we don't have the value of P. Okay, there's the first step there. We need to calculate the value of P. But it's only that value. But what's special is that we had mentioned that OKP, please remember from the previous question, this OKP is an isosceles. OKP is an isosceles triangle. So it means that these lines are equal, and therefore this angle and this one is equal. So it means if I can find this value, then I can calculate the value of O2. That is one step, or at least the minimum of one step. So we know today we'll need at least one. And then OKN. OKN. What is special about that triangle? The triangle has these angles in here. This angle is 64, this one is 52. But also, if we are to calculate the value of K2, we need to find the value of this angle in here. What else is special? So we have another step, which is 1. What else do we need? How is this going to link to us here? We know that angles in a triangle should add up to 180. So if we can find this one, then calculating the value of O2 will be the second step. Okay, just like in this one. So here we also have a minimum of 1. Let me repeat that. This triangle, we already have this value of O1, O2. Angles in a triangle should add up to 180. But we can calculate the value of this one. What's special about this is that, okay, different from OPK is that we have to first calculate the value of P. Then from value of P, we can already know that P is equal to the summation of K1 and K2. Then we can find the value of K2. So it means we need a second step rather than the first one. So when I said minimum 1 there, I was lying. It's actually 2. So this is, it's not complicated, but try and follow. We are looking for the easiest path. All of them are going to give you the answer. That's what you must know. You need to identify them, but which one will give you the answer quickly. But here, if we can find this value, we definitely have K1, because then we have a triangle that looks like this one, where we have O1 plus 2. We have this value of N, and then we have K2 in here. So if we already have the value of O1 plus O2, we can calculate this value, and then the values of a triangle should sum up, the angles there should sum up to 180 degrees. But what else is special about the triangle? This triangle has a line ON. There's also a line OK. That line is from the center to the circumference. What are those lines? Don't disappoint me now. We had mentioned that those lines, that's a radius, and radiuses will always be equal. So this line is equal to this one, which means we also have another isosceles triangle here. Isosceles. We have an isosceles triangle. What is special about the isosceles triangle is, first of all, these two are equal, but these angles are the same. So this angle and this one, they are equal. So if we calculate the value of this one, we already have that one. We are done, isn't it? Now let's find the value of this one. So it means, now we can sum up the values in the triangle. So O1 plus O2 plus N, but it's not just N, it's O, N, N. So there's two angles of N, so we can go for this route. So this angle is O, N, K. Then you add K2. This should equal to 180 degrees. I haven't looked into that triangle, you might have noticed. That's NKM. Because that triangle involves M2, involves these two angles. So we need to find, we already have M2, we need to find the value of N. And then from there we sum them up to find that they are equal, or to find the value of K2. But you see that there's an additional step. We need at least about 2 steps minimum. 2 steps. So this guy wins. So let's continue this guy. We have O1 plus O2, there's O1 plus O2, then ONK, this value of the angle of this triangle, and then we can find OB. But what's special is that we know that ONK is equal to K2, and those are angles, base angles of an isosceles. Those are base angles of an isosceles triangle. They are equal. So it means where there's ONK, we can replace by K2. So in this value here, we know that the value of O1 is 52 degrees plus 64 for O2 plus O in K is going to be K2 plus K2. Then this all sums up to 180 degrees. We need to also put the reason in there that we are summing the angles in a triangle, and those angles need to sum up to 180 degrees. So angles in a triangle, please don't forget that. So K2 plus K2 is 2K. We can take all of that to that side. So we have the sum of these 2K2 equals to 180 degrees minus 64 minus 52, and those are minus 52, that's 64 degrees. 64 degrees. And we need to calculate to divide by 2, So K2 is equal to 32 degrees. Okay, we've just found that K2 is 32 degrees. Now do you notice that K2 is equal to K1? And if these two angles are equal, and they are coming from this angle O and OKP, then that is being bisected. So therefore Kn bisects OKP. And we are done. All right. Thank you guys for tuning in. If you reached this point, it means you really enjoyed the video. Please give it a thumbs up. Press the subscription button, please. This is so that the video can be suggested to many other people who are very much interested in learning about circuit geometry. And also, the most important part, let's engage in the comment section. It's always good to ask. No question is wrong. Please just drop the questions in the comment section, and then we'll start from there. Thank you guys.